Very good morning, girls, and I hope you followed the previous classes. Of course, yesterday I didn't uploaded the videos. So today I am going to upload the two videos now because yesterday's class and today's class. Okay. So now you have to please observe that one. And one more thing here, in our previous classes we discussed some applications, right, which are related to the bisection method. And now also I am going to discuss the applications of the bisection method. But this one is somewhat different. Okay. Now write down the question. Find a positive root. Find a positive root between 0 and 1. 0 and 1 of the equation x equal to e power minus x. 2 TO2 a tolerance of 0.05 percentage. 0.05 percentage. Okay. So here the new word is nothing but tolerance. Tolerance is nothing but the error between the first one and the second one, but between the previous root and the present root, like that. And this is somewhat different one. Please listen carefully. I am going to discuss this one totally. Okay. And last few I will get. Now here see, the given function is this one. Interval is this one. Okay. So now here given that x equal to e power minus x, I am taking it as e power minus x is equal to 0. Now x minus, it can be written as 1 by e power x, which is equal to 0. Now minus 1 equal to 0, because here we can take the LCM, otherwise you can take another step also. Finally we have that x into e power x minus 1 equal to 0. Therefore f of x is equal to x into e power x minus 1, which is nothing but the function. And here we have the function. So here they gave this one, and finally every time we have to take the function in the form of some f of x is equal to this one. And what they mentioned, 0 and 1. So now let the interval is 0, 1. So now here f of 0. F of 0 means 0 into something will be 0 minus 1, which is nothing but minus 1, and f of 1. Okay. So f of 1 means 1 into e power 1. E power 1 is e minus 1. Obviously we know that e is a positive value, which is nothing but 2 point something, and minus 1 I have, right? That means obviously we will get that it is a positive number. Now here I am taking like this. Now here I am going to calculate the value of the x0, x1 and so on. So now x0 equal to 0 plus 1 by 2. So it is 1 by 2, means 0.5. Now what I have? I have that the x1, x0 value is nothing but 0.5. And now here I have to calculate f of x0. So of course it is nothing but iteration number 1. Now f of x0 means what I will get? 0.5 into e power 0.5 minus 1. Okay. So now here we have the value of the, if you are getting any confusion, then you can store the values with x1 also. There is no problem. Okay. So now here e power 0.5. E power means shift ln. Okay. E power 0.5 into 0.5 minus 1. Okay, now here we have the value of the f of x naught, okay, is nothing but minus 0.1756 now. So minus, we have that it is a negative number, and here what I have, f of 0 is negative. Now which one we have to ignore? 0. So then what we get? We will get the root between 0.5 and 1. So now minus 0.175639, which is less than 0. Therefore, the root lies between, what we have to write? 0.5 comma 1. Now we have to find x1. What is x1? 0.5 plus 1 by 2. That is 1.5 divided by 2. 0.75. Now iteration of course here what I have, x1 is nothing but 0.75, and here x0 is 0.5. The value is not similar. That's why we have to go for iteration number 2. Now f of x1 equal to 0.75 into e power 0.75 minus 1. Okay, now 0.75. Okay, first of all here I am calculating e power 0.75. Okay, and e power open bracket 0.75. We have the 2.11700 and into 0.75. Then I have minus 1. Directly I am calculating. Now 0.58775, which is greater than 0. Greater than 0 means it is a positive, so we have to ignore this 1. Therefore now what we have to do? The root lies between negative value is 0.5 and now positive value, which one we have to take? This one. That is 0.75. Okay, now we have to calculate x2. So x2 is nothing but 0.5 plus 0.75 by 2. So then what we get here? So if you get any confusion, once again I am saying you can take that x1 also. There is no problem with this. Okay, మీరు ఎలా తీసుకున్నా ప్రాబ్లం ఏం లేదు. అప్పుడు మీకు ఏంటంటే ఇటరేషన్ 1 దగ్గర 1 ని క్యాలిక్యులేట్ చేస్తాం అలా వస్తుంది. ఓకేనా? You can start with 1 or you can start with a 0. Now here 0.5 plus, now do that one, 0.75 divided by 2. 0.625. Here what I have? 0.75 I have, and now here 0.625. So when we have this one again, what we can say? We have to go for the next iteration. So before going to the next iteration, what they asked, the tolerance means error. Okay, now here the first tolerance. Enduku nenu first tolerance chesuna? Because tolerance means error. It is denoted with epsilon 1, 2, 3, 4 and so on. Now here x1 is a known value. First వచ్చేస్తుంది మనకి 2 iterations complete అయిపోయాక the formula for this one is nothing but x2 minus x1. Sorry. x1 is the common thing, so that's why no need to take because it is a given interval only. Now x3 minus x2 by x3 into 100. What they mentioned? They mentioned that it is 0.05% now. Now it is x3 means 0.625 minus x2 is 0.75 by x3 into 100. Now what I'll get? Divided by 0.625. Okay, and into 100. It is nothing but modulus we have now, so that's why it is positive. Now simply it is nothing but 20%. Epsilon 1 is 20%. Now actually it is near to 0.05 na? That's why we have to go for the next iteration. Now iteration number 3. F of x3 equal to 0.625 into e power 0.625 minus 1. So actually in the previous applications we discussed that same iterations and so on, but in this what we have to discuss? We have to discuss about a error. Error is called as here tolerance. అంటే ఫస్ట్ దానికి ప్రీవియస్ దానికి ప్రెజెంట్ దానికి డిఫరెన్స్ ఎంత అండ్ దాని నుంచి పర్సంటేజ్ ఫైండ్ అవుట్ చేయాలి. దట్ ఈస్ కాల్డ్ యాజ్ ఎ tolerance. ఓకే, so now here f of x3 we have now, so simply we have to take the calculation. E power 0.625 into 0.625 equal to value, so minus 1. So then we have that it is nothing but 0.167653, which is a positive value. So now here what we have to take? The root lies between. Where the root lies, ma'am? Positive, already it is a negative. So 0.5 comma 0.625. Next what we have to calculate? x4. Now x4 equal to 0.5 plus 0.625 by 2. Okay. Now 0.5 plus 0.625 divided by 2. Now it is 0.5625. Next what we have to do? We have to find the error. Now error is epsilon 2. Now x3 is finished now. Now x4 minus, and you have to observe that here we have 0.625 and here we have 0.5. That's why we have to go for the next iteration. Now here error is into 100%. Okay, so now here what we will get? x4 is directly I am taking 5625 minus x3 is 0.625 divided by x4 0.5625 into 100. Now it is nothing but 11.11%. Okay, so see here we have 20 and here we have 11. So what is happening? It is decreasing, right? So now here I am going to calculate the next iteration. So for the next iteration what we get? Iteration number 4. So now here in iteration number 4 what we have to take, ma? We have to take that same thing, okay, functional value, that is f of x4 equal to 0.5625 into e power 0.5625 minus 1. Same steps we have to repeat. So here they ask that about our tolerance, so that's why we have to calculate about error, otherwise no need. Now it is nothing but directly again e power 0.5625 into 0.5625 minus 1. It is minus 0.01278, which is less than 0. Therefore, the root lies between. So it is negative now. So 0.5 is negative there. So we have to ignore that. Now the new value is 0.5625 comma what? 0.625. Now x5 equal to plus 0.625 by 2. Now addition first mark plus 0.625 divided by 2. It is 0.59375. I am taking that simply 4. Now here epsilon 3, that is x5 minus x4 by x5 into 100%. Now what will be the answer? x5 is 0.594 minus x4 is 0.5625 divided by 0.594 into 100. It is 5.6 3030 and so on. So I am taking that percentage. So see, if you observe this one, what is happening? Obviously the error is decreasing, alright. So now here for x5 we have that the 0.594, otherwise we can take that exact also. Okay. So now here next one, after error what we have to do? We have to go for the next iteration again, iteration number 5. Next, f of x5, which is equal to 0.594 into e power 0.594 minus 1. Now calculate it. Now it is 0.07586, which is a greater than 0. Therefore, the root lies between one negative, that is 0.5625 is negative, and here 0.625 means new value is nothing but 0.594. Okay, next what we have to do here? We have to calculate x6. So x6 means 0.5625 plus 0.594 by 2. So now here 0.5625 plus 0.594 divided by 2. Now it is equal to 0.5782. Okay. Now we have to calculate the error epsilon 4. Okay. Now what is the formula? x6 minus x5 by x5 into 100%. Now what is x6? 0.5782 minus 0. x5 is 594 divided by 0.5782 and into 100. Now it is 2.73%. Of course we have some values, but here I am making up to 2 digits. Okay. So now here we have epsilon 4. Next, iteration number 6. Okay, and you have to observe this one. x5 is 0.594 and it is 0.5782. So first digit is same. After the point, the first digit is same, but after that, no. That's why next iteration f of x6 equal to 0.5782 into e power 0.5782 minus 1. Now e power 0.5782 into 0.5782 minus 1. Now we have that it is a positive value. So positive values means the root lies between, where it lies now? It is a negative, so 0.5625 comma 0.5782. Okay, so next here what we have to do? We have to calculate x7. Now what will be the value of x7? Equal to 0.5625 plus 0.5782 by 2 plus 0.5782. 0.5703. See here 5782 and next here we have 5703. Two digits are same. Okay, now here we have to calculate epsilon 5, that is x7 minus x6 by x7 into 100%. That is 0.5703 minus 0.5782 divided by 0.5703 into 100. So it is 1.3852 some percentage. So every time the error is decreasing, right? So next again what we have to go? Of course the value is not exact, so and we have to calculate the error up to 0.05%. దానికి నియర్ అయినా రావాలి లేకపోతే లెస్ దాన్ అయినా రావాలి. So that's why iteration number 7. Now f of x7 equal to 0.5703 into 0. And so on minus 1. Okay. Now 0.5703 into 0.5703 minus 1. Okay, so now it is positive only 0.00874, which is a positive. So what we can say? We can say that the root lies between which values, ma? Here negative and positive. Already we know that 0.5625 is negative and now 0.5703 is a positive. Now next value x8 equal to 0.5625 plus 0.5703 by 2 more. Right? Now calculate it. .5664. Now error E6. So E6 error is nothing but x8 minus x7 by x8 into 100. What is x8? This one. Minus x7 0.5703 divided by 0.5664 into 100. So it is 0.688 some 5%. See, the error is decreasing now. Here the value is x7 is 0.5703 and it is 0.5664. Again it is changed. So that's why next we have to go for the next iteration number 8. Now f of x8 equal to 0.5664 into minus 1. Now calculate it. So again we have in negative. Right? Negative means what we can say, the root lies between 0. Now this one, this is the previous interval, so we have to ignore the value of 0.5625. So when we are ignoring this 0.5625, the new value will be 0.5664, comma 0.5703. Now x9 equal to by 2. Now 0.56835. Now if you observe this one, here we have 0.5656 and 835. Okay, and now we have to think about the error epsilon 7 equal to 100%. Now 0.56835 minus 0.86564 divided by 0.56835 into 100. Now it is 0.3430%. Now if you observe clearly, now the error is nothing but what they mentioned 0.05. But what we have? We have that it is nothing but 0.35. Okay. So now here again I have to calculate the one. So one thing I want to check here, x8 is correct only, just I am comparing the values now, that's it. Yeah, correct only. Next, here the two digits are same, so that's why we have to go for the next iteration. Same procedure here we have to follow, but every time the value will be different and the interval will be different. So next here what we have? Iteration number 9. So first of all what we have to do? F of x9 equal to 0.56835 into minus 1. Now calculate it. 0.56835 into minus 1. Now it is again positive. Which is a positive means what we can say. Therefore the root lies between. Positive means what we have to take mark. The previous interval is this one. We have to ignore this one value. Of course, here we have positive. Now it is negative and it is positive. So we have to ignore this one. Now what is the new interval? 0.5664 comma 0.56835. Okay. Now x10. Addition of those two by 2. Now calculate it. Divided by 2. Now it is 0.56737. So I am making that 74. Of course 0.568 here it's 567. Somewhat near value but not exact. Now epsilon 8. x10 minus x9 by x10 into 100. Now 0.5674 minus 0.56835 divided by 0.5674 into 100. Now of course here 0.1674 percentage. Right? So now again here we have that 0.5674 only. That's why we have to go for the next iteration number 10. Then f of x10 equal to 0.5674 into e power 0.5674 minus 1. Now what I will get? First 5674 into 0.5674 minus 1. Now again it is positive. Right? Therefore what we can say? The root lies between. It is positive, so 0.5664. We have to ignore this one, so 0.5674 is a new value. Now what we have to calculate? X11. Now what is the value of the X11? .5669. Somewhat near, of course, very near value here. Now here 0.5669 and here 0.5674. Now I am calculating the error. Okay, error means simply epsilon 8 is finished. Now 9 equal to x11 minus x10 by x11 into 100%. Now x10 is 0.5674 divided by 0.5669 into 100. Now it is 0.088%. So what I mentioned 0.05 now, it is somewhat near value, right? 0.08. Now again we have to go for the next iteration because here we have 0.568, 567, 566, very near value. So if I take a new interval, obviously we will get some similar value. Now iteration number 11. F of x11 equal to functional value or substituted value minus 1. Now calculate it. Now it is 0.003029 positive. Therefore the root lies between. root lies between positive now. So negative value is 0. This one comma positive value is we have to ignore this. Then 0.5669. If you observe this interval, it is a very near interval now. Okay. So here what is happening? We are calculating the exact root in decimals. Okay. Now x 12. 0.5664 plus 0.5669 by 2. Now what I get? 0.5664 plus 0.5665. It is a very near value. Up to 3 digits we are getting the same. Now we have to calculate error. Error is nothing but E10 equal to x12 minus x11 and so on. This one. Now calculation part. Of course here we are getting the 6665. Okay, so 6665 also it is a very near value. 66 is same, and here we have 9 and here we have 6, just 0.0003 only. Okay, now here x12 minus x11 0.5669 divided by 0.5 into 100. Now it is 0.044 percentage. Now simply we have a very near value now, so again I am going for the next iteration number 12. Now f of x12 equal to 0.5665. Actually I have to get that 0.05 tolerance mark. So of course it is a less value, but here almost I have the same value. So that's why here just I am going for the next iteration, because there is a chance to get somewhat near value to the one. Now e power 0.5665 into 0.5665 minus 1. Original result ki cheseseyandi. Negative 0.001365, which is a negative. So now here what we have to do? We have to take that. Simply the value is nothing but negative. Now the root lies between 0.5665 comma 0.5669. Now we have to calculate x13. 0.5665 plus 0.5669 by 2. Calculate it. .5667. Yeah. Obviously, see here 6. 666 and here we have 667. Almost all near value. Now here error E11 equal to x13 minus x12 by x13 into 100. Now 0.5667 minus 0.5665 divided by 2. Okay, now it is nothing but into 100. So then what we will get here? 0.002 percentage. Okay, so now it is a very less error. Okay, so chala chinna error ochindi kabatti no problem. So now here I have that. Simply the error is nothing but 0.002. Now write down now. Now write down. Therefore, here the tolerance is less than less than once again I am checking. We have that it is 0.00888. Okay. So actually మనకి రావాల్సింది it is less than 0.05%. ఇంకా 0 zeros తో వచ్చేసింది. Okay. So now therefore here the tolerance is less than 0.05. Clear? So now this is nothing but the problem, and here we have to take that the tolerance and finally therefore write down. Therefore the root is 0.5667. 5667. What they mentioned, up to 3 decimals they asked na. So up to 3 decimal means therefore the root x is equal to 0.567. Therefore the root is 0.567. Okay. So this is nothing but the first application which is related to the errors. So in the next class we will discuss some more applications. Okay. And thank you girls. In the next class again we will meet. Okay. Thank you.